Welcome, network architects and AI infrastructure engineers. Today, we are deep diving into one of the most powerful diagnostic tools in the NVIDIA Spectrum networking arsenal, What Just Happened, or WJH. We will learn how to configure, stream, and analyze in-band telemetry to solve complex congestion issues in high-speed AI fabrics. Let's get started. Let's begin by defining what just happened, or WJH. In a modern AI data center, you are pushing massive amounts of data across 400 or 800 gigabit links. The what is simple. WJH is hardware-accelerated, ASIC-level streaming telemetry. The basics are that it monitors flows contextually at true line rate. Why do we need this? Because traditional monitoring, like SNMP, polls every few seconds. It averages out the data. If a microsecond burst causes a packet drop, SNMP completely misses it. But in an AI fabric running RDMA, that single dropped packet stalls your GPUs. How WJH solves this is by inspecting packets directly in the silicon. Our deep dive is the level of detail it provides. When a packet drops, WJH doesn't just increment a counter. It captures the exact packet header and tells you the specific hardware reason for the drop, saving you hours of blind troubleshooting. Look at this architectural flow. Incoming traffic hits the Spectrum ASIC. Normal traffic flows straight to the egress port with zero delay. However, the moment a packet experiences a drop or severe congestion, the WJH hardware agent intercepts the event directly in the silicon. It instantly extracts the packet headers and the exact drop reason, turning invisible failures into actionable telemetry. To appreciate WJH, we must compare it to legacy telemetry on slide 2. What are we shifting away from? SNMP and SFlow. The basics of these legacy protocols involve polling the switch every few minutes or sampling one in every 10,000 packets. Why is this a disaster for AI? Because AI traffic consists of massive elephant flows that synchronize across thousands of GPUs. If a microburst causes a drop, it happens in a microsecond. Polling averages the utilization over minutes, making your congested network look falsely healthy. How WJH operates is entirely event-driven. It sits silently until an anomaly happens, and then immediately fires off an alert. As we see in the deep dive, it categorizes these alerts. It tells you if the drop was a Layer 1 physical issue, a Layer 2 MAC issue, a routing failure, a buffer overflow, or an ACL block. You know exactly where to look. This diagram contrasts the two monitoring paradigms. When an anomaly occurs, legacy SNMP makes you wait for the next poll interval, ultimately averaging the data and missing the event shown in red. Conversely, the WJH path triggers an immediate hardware event, capturing the exact header and root cause with zero delay, shown in green. Now, let's get practical on slide 3. How do we actually turn this on? Configuring WJH on a Spectrum switch running Cumulus Linux is handled through NVIDIA, the NVIDIA user experience. The basics require you to stage and commit the configuration. Why? Because you need to instruct the ASIC to start mirroring these drop events to the CPU for processing. Let's look at the sample code. You stage the change with NV-set system WJH enable on and commit it atomically with NV-config apply. But there is a deep dive nuance here. NV configures the switch data store, but WJH relies on a Linux background daemon to format and export the data. You must ensure that the service is running at the OS level by using the system-to-enable and system-to-start commands for the What Just Happened service. Once both the ASIC and the daemon are aligned, your switch is ready to stream. Follow the configuration sequence. The administrator issues the NVIDIA commands to stage and apply the configuration. NVIDIA translates this intent down to the Spectrum ASIC, programming the hardware intercepts. Finally, the administrator starts the systemd service, bringing the WJH daemon online to process the hardware signals. Once WJH is enabled, how do you consume the data? Slide 4 outlines your primary options. The basics are that you can view events locally on the switch or centrally via a management platform. If you are logged into a specific leaf switch and need instantaneous data, the CLI is your best friend. You can use NVIDIA commands like nvshowSystem WJH packet buffer to instantly see what is dropping. However, in a 1000-node AI fabric, checking switches individually doesn't scale. That is why WJH integrates seamlessly with NVIDIA NetQ. The deep dive distinction is temporal visibility. The CLI shows you what is happening right now. NetQ ingests this WJH data into a time series database. This unlocks the NetQ time machine feature, allowing you to rewind the fabric state and diagnose a transient drop that crashed an AI job at 2:00 a.m. while you were sleeping. This diagram shows the dual pathways for data consumption. WJH events generated in hardware can be queried immediately via the local NVIDIA CLI for rapid, isolated troubleshooting. Simultaneously, the NetQ agent streams these events into the central time series database, populating the GUI and enabling historical analysis. On slide 5, we dive into advanced integration. What if you don't use NetQ? What if your enterprise already standardizes on Splunk or Grafana? You are not locked in. You can consume WJH via GNMI, the gRPC network management interface. The basics involve leveraging standard OpenConfig and NVIDIA-specific Young data models. Why is this powerful? Because it allows seamless integration into your existing DevOps pipelines. How does it work? Your collector subscribes to specific XPaths on the switch, such as the path for buffer drop reasons. Our deep dive is looking at the actual payload. The switch streams a highly structured JSON blob. It doesn't just say, packet dropped. It gives you the full 5-tuple, the source IP, destination IP, MAC addresses, and the exact string reason, like ingress VLAN filtering or source MAC equals destination MAC. This level of programmatic detail is a goldmine for automated remediation scripts. Follow the GNMI integration flow. The third-party collector initiates a subscription to a specific XPath via the GNMI server on the switch. The server maps this to the NVIDIA WJH Yang data models and streams the rich JSON payload back to the collector, which then populates your enterprise Grafana or Splunk dashboards. Let's apply everything to a highly critical real-world use case. Imagine your data science team reports that a multi-million-dollar LLM training job has suddenly stalled. You look at your SNMP dashboards, and the links are only at 40% utilization. Everything looks green. This is the ultimate challenge, silent drops. The GPUs are starving for data, but your legacy tools are blind to the problem. So, you apply WJH. You query the specific time window of the stall. The discovery is immediate. WJH flags hundreds of buffer tail drop events on the exact switch ports feeding those GPUs. The entire event lasted only a few microseconds. The root cause is instantly clear. An all-reduce collective operation caused a massive incast microburst where dozens of GPUs sent data to one GPU simultaneously. The port buffer overflowed. You found the exact problem in minutes rather than days. This troubleshooting flowchart highlights the danger of legacy tools. The stall happens and SNMP reports healthy, 40% utilization, a dangerous false positive. The admin bypasses this by querying WJH, which instantly reveals the buffer tail drop JSON payload, identifying the microsecond incast burst and providing immediate, actionable insight. Once WJH gives you the exact root cause, you can move to remediation. Knowing that buffer tail drops caused the stall, the network engineer can use NVIDIA to adjust the QoS settings. You might lower the explicit congestion notification, or ECN, thresholds to throttle the senders earlier, or fine-tune your priority flow control parameters. After applying these configurations, you use WJH to verify that the drop events have ceased completely. In summary, what just happened transforms network operations. It replaces frustrating guesswork with deterministic, silicon-level evidence. In the era of AI factories, this level of precision is not optional. It is an absolute requirement. Thank you for joining this deep dive. I invite learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. See you in the next session. Our final diagram outlines the remediation loop. WJH identifies the drop. The engineer updates the QoS policy and pushes the config via NVIDIA. You then verify the fix by checking WJH again. When the drops hit 0, your AI workload is fully optimized.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks, you can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper, it would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now the third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.